Welcome back. This is an introduction to accessing and integrating GIS. Oftentimes, people think of GIS as just making maps, but this isn't entirely the case. Cartographers, or map makers, do often use GIS to make maps, but a GIS, or Geographic Information System, is much more than that. GIS is a framework for integration, and Esri, an international leader in geographic information science, says that a GIS integrates hardware, software, and data for capturing, managing, analyzing, and displaying all forms of geographically referenced information. GIS allows us to view, understand, question, interpret, and visualize data in many ways that reveal relationships, patterns, and trends in the form of maps, globes, reports, and charts. It can help you answer research questions and solve problems by looking at your data in a way that is easily understood. GIS technology can be integrated into any enterprise information system framework. And with a little creativity, one can easily see how a GIS can be incorporated into most any type of community-based research, even at the most fundamental level, such as navigating an online map service. So, whether you're doing community-based asset mapping, revitalizing a housing development, or analyzing complex demographics and trends, a GIS can help you visualize your data more effectively than most paper and pencil methods. There are many types of GIS and even more types of data that can be used with one. In order to understand the potential of a geographic information system and digital spatial analysis, it's important for a researcher to understand what kinds of data they should be working with and which kinds of GIS software or services will most effectively display their data. Geographic data comes in many shapes and sizes. Fundamentally, there are two types of GIS data: attribute and spatial. Attribute data is non-spatial data that does not represent a location but can be linked to spatial entities, while spatial data refers to features that have a real geographic location. Spatial data can be represented in both raster and vector formats. Vector data is represented as points, lines, or polygons in two-dimensional space and is the most common data type for those starting out with GIS. For example, a tree along a road in a community would represent spatial data, a point, a line, and a polygon, respectively. But the type of tree, the name of the road, and the size of the community would represent attribute data. And raster data is just continuous data represented by cells, and this is beyond this conversation. Geographic data goes well beyond this, because digital data comes in different formats. These are just a few of the most common GIS data formats. It's important to understand these fundamental differences so that one can choose the right types of geographic data to analyze, how they can be integrated, and how to convert them if necessary. There are also different GIS software packages, which often only recognize certain formats. Some software is more difficult than others to use, as they usually offer more functionality, and those with less functionality can often produce quicker results, depending on the type of analysis or visualization you are doing. Oftentimes, a researcher will need to integrate GIS software and data in order to answer some geographic question. For example, you would like to visualize where fresh food markets are versus fast food establishments in relationship to low-income communities. But you collected your market data from a GPS survey, your fast food data from Google Earth, and your community data from a city in a shapefile. Now, how do you analyze and display all of this information together? This is why it's important to understand how to access geographic data, convert it, and integrate it across geographic information system platforms. I hope you've enjoyed this short introduction to accessing data and integrating GIS.